So this is also my starting point of my talk, and so I jump into the Micro Frontends here, some sponsored info, and then we start off with the table of contents. So I started with the front-end monolith. What is that? And I step over to Micro Frontends. I explain what it is, and I want to mainly focus on module federation, how you implemented it to create beautiful micro frontends, which is, I also show you a real world app which we created for the Dutch railway system. And it also contains front-end and back-end, of course. So micro frontends, you think about front-end, that is true, but there is also the back-end part is also a big part of it. So the name is a little bit confusing. And I show you also the steps, how we go to production. And when I have time left, I also discuss with you the lessons learned, but I think I'm running out of time then. So here I cycled 25 years ago from the Netherlands here to Nepal and Tibet, and there I bought this hat, and here I'm cycling, quite younger here in Nepal, and we were cycling here also with a guy from Australia, from Brisbane, and a friend from England, and I was starting on my own at first. And I met them, and we are going to visit a park, Bardia Park. And here is the lodge, the jungle lodge. And we want to see some wild animals there in Nepal. So I saw suddenly a silhouette of a rhino when we were walking there. So we were walking there with the two guides, and he said, "Oh man, what did you do? What are you looking there? You have to climb into a tree, and everybody has his own tree." So I climbed into a tree with a big branch, and the guy was yelling too loud. I say, "Oh, don't make too much noise," and his ears were steering like radars, so it was very dangerous. And suddenly he walks towards my tree, and the branch was as high as his nose, his horns, so you feel it. Here he is running. How fast can an Indian rhino run? How fast can he run? Who thinks A? Yeah, you? Okay. B? No. C it is. Unbelievable fast. So he stands under my branch. So I'm Peter Eijgermans from the Netherlands. I'm a front-end, coach with front-end. And we are part of Ardina, and the big company is called Soprasteria. We started here with the monolith because the rhino is also a monolith, and I want to defeat that monolith in this talk, because a monolith is one. You know it. Everything is tangled together, the front end and the back end, and that is sometimes a problem. Not always, of course. But so we split up our applications in layers. You recognize that, so you think that is a solution. But when you change something in one layer, you have to change also the other layers. So you have a ripple effect, you can say. And then we stepped over to the microservices part. So the backend, we split it up in parts. You remembered, you recognize it already, of course. And every micro frontend, of every microservice has its own database. But the frontend is still a monolith, so this is not what you want. So we want to, also split that up in little parts like microservices. That's a simple starting point. So micro frontends are born, you can say. What are micro frontends? You can imagine that you have one monolithic application with three components. One component is categories, and we have a component about products, and a component about the shopping cart. And for each component, we can create. We have a team who worked on it, and all the teams are working on the same code base. So you have to, it's a little bit difficult to manage the code and to test it, and because everything is tangled together. So we decided to split this simple application up. This is only an example application a little bit to explain it. We decided to make apps of those components, separate apps, and those apps are called Micro Frontends. So they run remotely in a distributed way. There's one team is responsible working for the categories application, and every application has its own pipeline, its own code base, its own repository. So every team can work independent of each other. This is what the goal of Micro Frontends. So you can speed up delivery of your products. Okay, this is the definition as an architectural style, Micro Frontends, where independent deliverable frontends are composed together. Why Micro Frontends? Okay, well, I told you already, you have incremental upgrades where you make little parts of the application, and when the application are small, like the categories or a products list or the shopping cart, then every team can focus on it as its own code base, its own pipeline, so they can deliver fast your deliverables. And you have to define clear boundaries. You know that all. I think we used for our application domain-driven design to define clear boundaries, so every team can focus on one application very well, and they don't have to collaborate too much with each other. So this is the biggest goal of Micro Frontends also, that you can freely work on one application. You can reuse all those applications quite easily, and independent deployment stands for the pipeline. Every Micro Frontend has its own pipeline. The code base is much simpler than a monolith. Agnostic will say that you can build your shopping cart in Angular and your product list in React, for example. It's also possible. And the teams are working independently on each other. You can also say that the application looks like verticals. What are verticals? You can say that Micro Front applications not only is about front-end, but also about back-end. And when you see a vertical, you have in the top, we have a host or a container or a shell application, which is responsible for rendering the Micro Frontends itself. And also for routing, it is responsible, and also for the communication between Micro Frontends. And what I say, every Micro Frontend contains front-end and back-end. And you see that Team A is, for example, focused on the categories. There's in cross-functional teams, and they work on their own, and and you see that there is some connection with it via events. So they talk with each other, the Micro Frontends on technical level via events. But in this talk, to make it not too complex, I only focus now on the front end, because the back end is, when I do that, I've also given talks in the past about the other parts, so you can look it on YouTube. Here I'm focusing on these applications. We've created, say, an application like this one, for example, and also this. Does it work? Okay. Oh, here it is. This application and this part of the application we've created with Micro Frontends, and I showed you how we've done that. This application is for the Dutch railway system, and you can see some planning information about your other trains. You can see trains driving in parts of Holland. This is the application, for example. You can load multiple on the left-hand side, multiple emplacements, we call it in a little bit the French term, places in Holland, Utrecht, for example, and here in Amsterdam. You can follow the trains. It's all real time, So we work with WebSockets. This is a very interesting application, but and also in the middle we have train information, planning information about the trains itself, and then on the right-hand side you can see on the whole stretch of a, for example, from Amsterdam to Utrecht, you can see which trains are driving in front of you and behind you, and what the delay is or not. So that is, can I? Not always work. You see a red one. You see that this train is driving behind this train, and this train has a delay. So that is why it is red. Okay, this is the applacementen. Let's go further with the micro frontend. Firstly, we start with micro frontends with web components. This is okay. It is quite old, but it was good to start with this to split up our application into web components. But it was slow. Our applications consist of three parts: the applacement viewer to follow the trains in different parts of Holland, so Amsterdam or Utrecht. And the plan viewer I showed you already, and the baanvak I showed you. And for every micro frontend, as for our applacement viewer is a micro frontend, we have to load Angular. So that is not what we want. That we want to load Angular multiple times. You can also use React, for example. No, but I show you now an application about Angular because we work with that. You can also build your application with multiple languages, with Angular, with React, and with Vue for the third application. No problem with its framework. Or you can work with JavaScript. It's all framework agnostic. Okay, I'll show you later what is the tool what we use. But it's very slow because we have to load Angular and also our shared libraries, for example, Lodash, or the ArcGIS, some other shared libraries you want to use. Yeah, they are also loaded multiple times, so very slow. Yeah, here, this is the tool we are using now, Module Federation. I'm very glad that we started with it because we are such a very huge application we've made, and we have to make a lot of choices, and we created an application at first sight with Webpack. Is this one? So Webpack is the first one we started with, and it is quite good option to start with Module Federation. And you have also Vite and ESBuild, where you can also use Rollup and Native Federation. That is the one we have also now implemented in production, and that is a very fast one. How do we implement, how do you use such a framework? A framework works all together the same, you can say, that's good. They have the same configuration, so that is quite clear to explain then. You have two roles in application, the host and or the container and the shell, I call it, and the remotes. And the remotes are our micro frontends, and the host, that is our container application. And in the host, you define only the URLs of the micro frontends you want to use. So the micro frontends, we call that remotes, have the name MF1, and the others have the name MF2. And you see that the remote also exposes a module. You can also expose a component. In this example, we expose a module, and then we can also use that micro frontend in the shell via the URL. I show you later how I come to that URL. You have also another part in the configuration, that is the shared part. And here we define our shared libraries. So we want to share Angular for Angular Core. And we defined here also the properties singleton true. That means that we want to load Angular once. That's what we want because the application is now very slow with web components. And with this tooling, we can load it once. Our required version is 17, and that means that you have also compare with the versions here in the remote. Always the highest compatible version wins. So in this case, version 17 will will be chosen to download. And also, strict version is true will say that you that it will throw an error when there are compatibility errors between versions. That can happen. When you define in this configuration singleton false, then still Angular is loaded multiple times. So this is not what we want, of course. So it's better, of course, to define it as singleton true. So the shared libraries are loaded once, and that is very fast. Our application was speeding up from 20%. You can imagine 100% is the very fast application, and we're from 20% lighthouse score to 80%. So this very happy about it. So everybody wants to use the application now. We have also native model federation. There's another taste of the model federation framework. It uses the same configuration, but it is browser native, and it is independently, it is built to agnostic and framework agnostic. You can use everything framework you like. And you have also using the same mental model of a model federation, so that means that you can configure it the same way. Embrace import maps, and it is fast because under the hood it uses AS build and also caches your shared libraries. You have to load it and it also caches it. So this is why we stepped over to native, so the application going faster and faster from 80 to 90%. It's unbelievable. So, and our application is much faster than also web components, but also much faster than the monolith. So it's worth it. Here you see a layered architecture of the module federation. You see here underneath you have the native federation core, and that you can use that for the main frameworks like React and Vue. But for Angular, we have on top of it, we have to use a different package on top of it. There's Angular Architects, Native Federation, but you can also implement your own federation layer. It's not so difficult, but I have no time for it to explain that. So I'm standing still on that branch, and the time was, it's unbelievable. The rhino was standing there, and I was thinking, shall I jump to one tree? Shall I step off and running zigzag away? What shall I do? The time was, it was seconds, but it's amazing. It was a lot of time it cost, I think, for my feeling. But it was, I want to show you a real app we've created, the track viewer. In Holland we call it the spoor viewer. Little okay, so 3 minutes. Here I show you the application we've created with 3 micro frontends, the emplacement plan viewer and BAVAC viewer. Those are called the remotes. And here we start the application, and there we logged in here, and I try to show you the sources, resources with the WebSockets I use. 5 WebSockets we use to follow the trains and the train tables. Here we define here our emplacement viewer and also plan viewer, and you can load it multiple times. That's also interesting about the application. It is not very static. Plan viewer, and here I select a BAVAC viewer. So, and I save it. I select Utrecht, for example, and I can follow here some trains. And I can also change the settings, what I want to see, bridges, tracks, trains. Here I have the plan viewer of, what was it? Dordrecht is also a little city in Holland. And here you have also, you can zoom in, of course. Okay, you have a lot of settings here. You can also filter on I do it here on a train. It's a very huge application with real-time information. I will show you some code of I've made a very simple application only to show you how the communication works between Micro Frontends. I was not allowed to show the real code of the application because I can show you only this, how it works, and I show you a sample app. Show you the main basics of this app, how we created it. It's no rocket science, but it is, you can achieve a lot. Here you see that you can also focus on one element on the screen, for example, on a platform. Here I'm seeking here on a platform, and I also want to seek, and the other one I want to seek here on the train, I think. Yeah, okay. Here you see that I focus on it. Okay. I think the movie is now ready. Yeah. Okay, and here you see also a lighthouse and a network tab, and I show you how the WebSockets are loaded, and you can see that a lot of data is coming in, real-time data about the trains we are following on the screen. So, okay. Let's go further. Wait a moment. Right. Okay. Where's my pointer? Does it work anymore? Can do all things together, I think. I see. It is frozen now. This is not good. I also train. I can also add tasks here, of course. Train 2 to the task list, and train 1 is it broken or the track is okay, etc. Track 8 is blocked. All those tasks I have to do. When I do another task, I got a message. So this is all about communication. I show here communication about how I communicate from the Micro Frontend to the host. And also I want to communicate from the host back to the Micro Frontend. And that's here the message. This message comes from the shell. And these tasks come from the Micro Frontend. So how do we create such an application? Here I have a monorepo. A monorepo is nothing more than one repo, and there you have inside of it you can have multiple libraries and multiple apps. And I've defined here my Micro Frontend and the shell application, and also 2 libraries for authentication and filter. A filter I use that for the dark mode and light mode. So, okay. Start with the package.json. Here I would define in package.json my dependencies. It's like in Angular or C#, you have also a dependencies list of what you use. And you see that I use mainly Angular in this application, and also native federation I use here. I can also use this for React or Vue, so it's not a big deal to step over to another framework. But I'm now focusing on mainly on the front end and on Angular, of course. And how do we make the Micro Frontend itself, the remote? For the remote app, we firstly have to configure what we want to expose to our shell. And you recognize it already in the slides. Here I expose my app component. And I want to also define what I want to share. Now, in this one-liner you see here, to share all. That means that I share all these dependencies at once. You can also define that in that way. And I've also another section, a skip section, and in the skip section you can skip what you don't want to load at runtime. This is beautiful about multi-federation. Everything is loaded at runtime. So when you make a change in the Micro Frontend, you see it directly on the screen. You don't. It's not at build time. It's all at runtime. So your Micro Frontend app, and what do we have here? We have here the main TS file. This is the bootstrap file. I had to start up the application. Like in React, you have the same. In Vue, you have to have a bootstrap file. And there we do init federation and starts it up. Our first component is our app component. That's our main component. And what do we do here? I have here HTML. It's a lot of looks like a lot of code. Here only I show you here. I render here the image of Angular. I show your username, and I have an input field for adding tasks, and a button to add task to cart. Let's go to that method. So that's very okay, understandable. Task. I create here a task of type task, and then an ID, name, and date, and I stringify it with JSON stringify. And then I emit the task to my shell application with the on-app state changes and variable I've defined here upstairs as an output variable. So this is the way how we communicate back to the shell. On app and here in the shell application we can subscribe to that field. So when you go to the shell application, we have also here it's not so difficult, but looks like here it is. You can subscribe here on the on-app state changed. How do I set this up? As follows. I load here my emplacement. That is that emplacement button I have pushed here to show here my Micro Frontend. And then this method will load a remote module with the name Micro Frontend 1. This is my Micro Frontend. I want to, and how do I know that this this Micro Frontend is loaded via my assets? I defined here my manifest file, and here the shell knows via the manifest file which Micro Frontend I want to load. It has the name Micro Frontend 1, and it is running on this URL. So when I type this in, you see here that this is the way how the shell connects with the Micro Frontend, with this remote entry file. And you see here that it has the name is inside of it, and also is defined what we want to share with the shell application. So the load remote module picks up that remote JSON file, what I showed you with this construction. And I grab the module of the Micro Frontend, and I dynamically create the component via a this is a construction container ref. What is that? Okay, let's go to this is the container I want to load in my Micro Frontend. Okay, here upstairs I defined the container ref, and it's referencing to the remote container. And remote container is defined here in my HTML. This is the place where I want to load my Micro Frontend in this container, and I can grab a reference to it in the app component. So here is the container. I have here a reference, and via that reference, I can create a component reference, and I can get the instance of the app component. So it is a few steps to get the real instance of the Micro Frontend, and then we can subscribe on it. And when we subscribe on it, we can receive tasks, the task we added, and we push it in an array. And when the array exceeds the amount of 2, then I send a message back to the Micro Frontend from, hey, the amount is greater than exceeds 2. Okay. when we went to production, we have taken a lot of steps, of course. And first of all, of course, the CI/CD pipeline we have to configure. CI/CD, everybody knows that's for okay. 4 stages: source, build, test, and deploy. So when you change some code and you place it in your repository, then the CI/CD pipeline will be triggered to build a runnable instance, and then the tests are running, integration tests and unit tests, and automatically it will deploy your application on all your environments. That is what you want. And the main thing is, of course, that that it is that is all automatic, and that you have fast cycles to deploy, and that you have fast feedback from the users. This is what we want. And every single micro frontend has its own pipeline. I have 5 minutes left? Okay. And also we deployed an application on the static content server. That is quite cheap to do that. We have not to deal with Docker files or cloud. So this is for us suitable to deploy our micro frontends on a static content server like Nginx or Amazon S3 or Azure. How do we config our manifest? Is a very important one. We have to define a few manifest files for all our environments: acceptance, product, test environment. Here you see an example of the product manifest with URLs for the product, for the remote and for the product environment. And this is also the way we communicate with the micro frontends. And the main TS file we have to normally we define here in the main TS file also our manifest file we want to use. But it is not handy when you want to step over from the production to acceptance or acceptance test, or we want to test our local environment. We have changed this file. That's not what we want. So I expanded this file with a switch. So when I have work on production, I use the production manifest file. And when I use acceptance environment, I step over to that manifest file. And via that location, it contains the right manifest file, and then I can bootstrap application with the right URLs. Dependency management for managing dependencies is also very important to register your current version. Here you see package JSON, also dependencies with a lot of dependencies, with a lot of versions. Register it, specify it, so you know what is the version of your dependencies. And also you have a lot of versions of your interfaces between micro frontends. You have also defined that. Here in the federation config file, you have to define what you share. In the host, you have also to define what you want to share. Versioning is important. You have to use semantic versioning. There's 3 numbers about a major, minor, and patch release. So you know how much impact one release has. Dependency injection. You can, with module federation, you can inject your micro frontends in a dynamic way. A backward compatible testing. Version control is interesting, of course. And versioning development. Let's see how we do that in our application. We a lot of versions of micro frontends, and we give it the same name as our repository name. So this is our static files, static application, which is running on the static server. Security, I don't want to tell too much about it because I'm running out of time, and we use the Azure DevOps VSTS package for security. It's very simple to set up. Make use of access and refresh tokens. And load your, you have to load your test. You have to test your load, do some load testing, and monitoring your is also very important for the application, of course. I think it is time to stop now. Lessons learned takes too much time. 1 minute is too short. Sorry? Huh? Yeah, I stop, I think. So I only want to do this. How do I survive the charging rhino? Who thinks A? Make yourself big and make a lot of noise. Nobody? Runaway zigzag. Have I done that? Really? Okay. A tiger comes by. A tiger comes by. Well, there's another story. You see? And my friend took a photo of the rhino. Yeah, really? Okay. That's true. The guy, this is the guy, and he is he's called Chris, and he lives in Brisbane, so I'm going to meet him. The rhino is running away. He feels himself like a very tiny and flexible, adaptive, micro. So he runs away. So I defeated the I've defeated the monolith. Sorry, sponsored. Thank you.